All right, so we're going to continue on. We're on page 11. Thank you. Page 11 of your packet, page 5 of your reference table. We don't have too much to do. Yesterday, we talked about mid-ocean ridges yesterday. Guys, where will we find the oldest rocks around the mid-ocean ridge? The furthest away, because remember, the babies are born at the mid-ocean ridge, and they get older as you go out in both directions. And then just remember that whole reverse polarity stuff. They go out exactly the same. So we start with normal polarity, north pointing north, south pointing south at the ridges. And then when you go out to the next layer, we get what was called reverse polarity, which again was just south pointing north, north pointing south. They're reversed because magnetic north has switched. We don't know why, we don't know how, we just have evidence that it has happened. It's further proof that the plates have spread apart. This is almost always on the regions as well. You need to know both those concepts. Youngest rocks at the ridge, older rocks as you go out, and they just reverse themselves in that same pattern. Normal, reversed, normal, reversed. Okay, so that was that part. We did talk about, so that was called paleomagnetism. We talked about that. We did yesterday, so on Tuesday, talk about this was all, this right here, these 3 bullets were what Alfred Wagner was missing. If he knew about the fact that they were younger at the ridges, older as you went out, he would have had further proof that says, hey, look, they must be moving. He could also then talk about, like we talked yesterday, no, I guess I got rid of them here. Okay, where'd they go? Okay, so not sure why I had a question about earthquakes in there. The other stuff he was missing is what we talked about yesterday, how those fossils, how could a fish get on top of an ocean or on top of a mountain? Yeah, he climbed. Yep, flew, he jumped. No, fish used to be at the bottom of the ocean when those plates were nice and flat. But then when those plates collided and formed a mountain, the fossil of the fish went from the ocean floor to the top of the mountain. The opposite of this was that subsidence of fossils, where you had fossils that were living in shallow water. And because of plate tectonics, those plates had shifted and dove very deep under the ocean. So those are both evidence that the continents are moving around. You don't have to write that. There's nothing here to write, but I also want to talk about rock layers. When we talked about sedimentary rocks last chapter, we talked about how they're formed in horizontal layers. Well, those nice horizontal layers, it's not how we find them in real life too often. What? So they're formed in these nice horizontal layers, but they could get tilted, folded, or faulted. So they could get turned on their side, smushed all together, or broken in half is really what this is saying. So when those continents are moving around, they can actually mess up rock layers. So that's another piece of evidence that says the continents are moving. The last thing that we need to talk about on page 5 is hotspots. So this is still on page 11 of your packet, and there is something called a hotspot there. It's at the very bottom over to the side. A hotspot is exactly what it sounds like. It is a hot spot on the earth, on the earth's surface. It's a place where magma is actually coming up through the earth's crust. The best example of this is Hawaii. If you could, when you're done writing, go ahead and look at page 5 of your reference table. Find Hawaii on there. It's labeled Hawaiian hotspot. Find the Hawaiian hotspot on your reference table, page 5. I'm assuming you guys already are familiar with the fact that Hawaii has lots of volcanoes or is a volcano. Hopefully you knew that. If you didn't, it is, yeah. Whoa. Yes, Ray. So if you didn't already know that Hawaii was a volcano, just take my word for it. It is. We're gonna kind of go through it a little bit already. But here's one of the things you need to be able to make a connection with. Point to Hawaii for me, would you? What's weird about the fact that Hawaii is volcanic? It's in the middle of a plate. Where this whole past 3 weeks, where have we said all the earthquake, mountain building, and volcanoes take place? I have hopefully drilled that into your head that earthquakes, volcanoes, mountain ranges, they happen on the edges of plates, where the plates are bumping and rubbing and pulling apart from each other. That's where things are happening, at the edges. So it's super weird that Hawaii, in the dead smack center of a plate, is a giant volcano. And that's because it's what's called a hotspot. It's a place where magma is coming up through the Earth's crust. And it's just a random spot. Now, can I exit this? Let's see. No, it's not looking promising. It looks promising here, but where? Preview? No. So anybody know how I can find the link that I hid underneath this picture? No, I did format video maybe? So I turned the link into a picture back when I did this. But now it's video format. Darn it. Let's see if I can just go find it on the internet. Okay, well, this is at least part of the explanation I wanted. So this will have to do. Let's see how this works.
A hotspot is a localized source of high heat energy that sustains volcanism. It is not an isolated shallow magma reservoir beneath the crust, nor is it a pipe of magma that streams from the outer core. One theory holds that hotspots may begin as a blowtorch-like thermal perturbation in a zone between the liquid outer core and overlying mantle about 2,900 kilometers deep. The thermal plume allows solid, yet mobile mantle to rise very slowly and convect outward. Convection is the process by which heated material rises and cooler material sinks. Although magma may be generated as deep as 1,500 kilometers, individual blobs do not traverse the entire mantle. Let's zoom in to look at the onset of hotspot volcanism beneath a moving plate.
So that whole part,
As each pocket of
that whole part was just explaining how the hotspot got there. You guys actually don't need to completely understand how a hotspot gets there. Know that it has to do with heat and convection. That's good enough, okay? That part was just knowing heat and convection makes a hotspot happen. This next half, this is the part you are responsible for understanding. And I think it works better watching a video that has these animations than for me to try and demonstrate it. So this is how we're learning about hotspots, not how they form, but kind of how they work after that. So again, this is the important part right here.
melt stalls. Its heat is transferred to adjacent rock.
Still working on that.
This transfer continues to the base of the tectonic plate, where decreased pressure facilitates rock melting.
So
The magma that forms at the base of this plate rises through the plate in a network of cracks and shallow chambers and erupts on the surface.
Okay.
Over hundreds of thousands of years, large volcanoes build on top of the plate. The weight of the volcanoes bends the plate downward. Volcanoes that spent their constructive life over the thermal plume slowly get rafted away on the moving plate, and new volcanoes build in their place. Multiple dikes can feed several volcanoes from separate conduits. The moving plate drags the thermal plume with it. This can explain why volcanoes can erupt again after centuries of quiescence, even after they have moved off the center of the hotspot. However, erosion greatly outpaces volcanism as eruptions wane, and the buoyant effect of the plume diminishes, allowing the volcano to subside.
Okay. So there's a lot going on there. So it starts with Hawaii. Yeah. Starts with one little volcano forming under this area in the mantle. Now, guys, remember the mantle doesn't move. Only the lithosphere moves. So we've got this mantle hot spot. The hot spot stays still. And that hot spot was able to leak some lava up through the lithosphere because it melted through the lithosphere and form one volcano. So there's one area where the lava sneaks through and burns and makes a volcano. It was originally an underwater volcano, but it grew and grew and grew so that it was big enough that it became Hawaii. But then what happens after there's one nice, lovely volcano? What did the video say happens next? It makes more, but how does it make more? What has to happen first? Yeah, charades again for the win. Okay, the plates moved. So then this lithospheric plate, so the dark brown and the light brown, that's the rigid mantle and the crust, they move. Just like we've said has happened all the time. The plates move. So the plate moves and takes the volcano with it. And what happens after it's moved the original volcano? What then happens after? Makes a new volcano. So now directly over the hot spot, a new active volcano is forming. Another island is growing. Some of them can still erupt because they're still a little bit connected, some of the original volcanoes. But as that video showed, the farther they get away from the actual hot spot, those will start to not be able to reach the lava anymore. They won't be able to produce new volcanoes down at that end, but there's always a new volcano growing over the hot spot. So we put it like this, and you get this whole chain of islands. And here's where I'm not sure how much you guys know about Hawaii. So yes, Hawaii is a state. Has anybody been there? Oh, good. I don't have to hate any of you. Sorry. I get a little jealous when people have gone to Hawaii. So I don't know if you know this about Hawaii, but it's not just one large island. There is an island named Hawaii that is currently what's called the Big Island of Hawaii, but there's other smaller islands that make up the state of Hawaii, and it's a chain of islands. If you've ever seen different TV shows that are filmed in Hawaii, they often are in helicopters, like what was it? Hawaii Five-0. Duh. They're always in helicopters going from one island to another. Yeah. That's the other one. I like that one because it's got Dobermans. So I'm a little, right? That's the one that's got the two Dobermans. I don't actually like the show, but I like the Dobermans. They're always in helicopters or boats going from one island to another. You really can't just like drive to them. There's not even bridges that go from all the islands to each other. I believe there's a couple that have bridges. So this is exactly Hawaii. So the Big Island of Hawaii is the one currently over the hot spot. It's currently getting bigger and growing, but these other islands are much smaller. Any ideas why some of these islands that are not currently over the hotspot might be smaller? There's two excellent, maybe three excellent explanations. Give everybody a minute to marinate on that. So again, what am I asking? Why are some of the islands that used to be on the hotspot smaller than the one currently there? There's at least three good reasons. So TJ, you had your hand up first. What do you think? One would be erosion. You guys, we haven't done it. This next chapter is erosion, but hopefully you remember some concepts of the erosion. Wind, water, glaciers, waves, they can all wear down things. So these islands have been out there for millions of years, surrounded by waves, getting rained on and winded on, if that's a thing. They're breaking down, they've gotten smaller. So erosion has caused these islands to shrink. There's at least two good more explanations for why they might be smaller or why Hawaii is bigger. Can you think of it? Think this over. Why might an island be smaller than another one around it? Don't make TJ answer this.
TJ answer it.
No, I want Nick, what were you gonna say, erosion, when you had your hand up? Okay. Nobody can think of an explanation of what, you got an idea?
Yeah, that's right. Like that.
Yeah, so Hawaii could be, the big island of Hawaii might be bigger because there might be more lava there. That might be what, is that kind of what you're saying? There might be more lava shooting up. That's an excellent explanation. Or maybe there was less lava coming up for the shorter guys. And the last explanation, anybody got any more ideas of why it might be bigger or smaller? You want to try?
I was gonna say, Hawaii's still active.
Yeah, the one that's currently over the hotspot, so the big island of Hawaii, that is still active. I believe the second one over also has some active volcanoes on it. One other explanation that they have is that the plates have changed speed. If the plate has slowed down, the island gets more, or the volcano has more time to build up. Or if the island was moving, or if the plate was moving faster, it wouldn't have time to build up as much lava. So those three explanations, so the amount of lava, the amount of time, and then erosion, explain why the islands are all different sizes. So for this, on page, I think it's 12, you actually have a map of Hawaii there. So let's see what kinds of things the regents will ask you about Hawaii. I think I have this in a PowerPoint. Oh, no, I'm sorry. And I guess it's page 14. Page 14, I'm sorry. What's on page 12 of your packets? Stuff, practice, those practice questions that we already did. Okay. You did do them. You got a handout though. They were before I gave you these packets. Oh, and all that time, the link was on the next slide. Oh, well. So you see this picture of Hawaii. So what this is, so first we've got the like zoomed out version, and you might be able to match this up with your reference table a little bit. Right here, these 1, 2, 3, 4, 5, these 5 islands right here are the state of Hawaii. But if you zoom out, you can see that there's actually a whole chain of these. Where did all of these come from? Where did this island right there, or that little underwater mountain, where did it used to be? Over the hotspot. This again is what Alfred Wegener was missing. If he knew this about Hawaii, that there was this whole underwater chain of mountains that actually were dormant volcanoes, he would have been like, oh, the only way for that to form is it used to be here. And it has since shifted up this way. So you'll also notice that these ones that are nearer the hotspot are much bigger than most of the others, again, because they haven't been exposed to that weathering and erosion yet. So then what they did is they took this zoomed out version and then zoomed in. So you just see the 7 islands. One thing I don't like about this image is they tell you how old each of these islands were. Even if those dates weren't there or those ages weren't there, if I said which one's the youngest, would you have been able to answer me? No. Where would you look for the youngest one? The closest to the hotspot is always the youngest. Then they get older as you go out. So that's perfect. Let's just make sure you can answer a few of these questions. Which one is the oldest? Kauai, yeah, I think that's how you pronounce it, Kauai. So again, even without the dates on there, you know that's the oldest because it's the furthest one away. So then which one's the youngest? The actual big island of Hawaii. Again, even without the dates, you should be able to figure out that it's the youngest because it is the one currently closest to the hotspot. From your reference table, what plate is Hawaii located on? It is right in the dead smack center of the Pacific plate. So which direction is this plate moving? North-ish. How do we know it's moving north-ish? Let's take a look at this map. Okay, makes sense? So if right here at the hotspot is where the islands have to be made, where was Kauai when it was made? Where was it? Somewhere over the hotspot. So this island right here used to be there. So if it was here originally and now it's over there, it's moving that way. First of all, is that perfectly north according to the key they gave you? No, it's not perfectly north. What would you say? Northwest. So the plate is moving northwest. Here's a think about it question, number 24 that's listed there. Make an inference, which if you remember from day 3 of this class, an inference is a guess based on your observation. Why would the island of Hawaii be larger than any of the other islands? So this, we just talked about it. The plate could be moving slower. That's one. Put that down. Number one, plate could be moving slower. What's another explanation of why Hawaii is larger? Huh? No weather. It hasn't had enough time to get worn down from weathering and erosion. And the third explanation, again, could be that there might be more lava coming up now than there was when Kauai was there. And here's another food for thought one, number 25. Another island is forming in the same area. Looking at the chain of existing islands, where is the next island going to form? South which? Southeast of Hawaii. In other words, here's Hawaii right here. Hawaii has moved a little bit off of the hotspot, and a new island is going to form right there over the hotspot, which is southeast of the big island of Hawaii. So another Hawaiian island is currently starting to form. And finally, this one we haven't really talked about it, but there's a name. Over the last 100 years, most of the world's earthquakes have taken place in a region along the Pacific Ocean known as, does anybody know what this area is called? This is the Pacific Ring of, okay, well that video started off with a perfect, no, it's not gonna show it. Does it show it when I go out? Yeah, that area right there. This is up there, that's the Alluvion Trench, down to Japan, the Mariana Trench, over to the Peru-Chile Trench, up near the San Andreas Fault. This area is known as the Pacific Ring of Fire. What I would like you to do for homework is just that flow chart on page 15. This guy right here, do you have that? Page 15. Probably should have done this before the quiz yesterday, but it's a perfect place to add, to wrap it up today. So your homework is just fill in the empty boxes on page 15. Great. Kat, did you get anything done? Oh. If you want to come down tomorrow for period to work on your missing labs, that would be a good idea.